Hello class, this is going to be a video on the adding and subtracting of algebraic fractions. But before we begin, I'm just going to have some spare paper here with me because I'm going to be using it a lot. Okay, have some spare paper here. And it'll serve two roles for today. It'll block off this one and it'll help me focus and help me have some scrap writing paper. Okay, and just so you know, before we begin, if you don't remember, when it comes to fractions, they must have the same denominator before we can add them. By that I mean, if you thought that this is 5 over 6 plus 3 over 8, this doesn't become 5 plus 3, 8 over 14. This is very, very wrong. Okay? If you don't remember that, remember it now. Okay. So when it comes to these ones, what we want first is we want to have the same denominator. Okay? So by that is we want the lowest common multiple. Okay, so I'll just get rid of this one. So what I do, this is all done in my head, but I'll use this to visualize it. So I'll go with 6 first. We do multiples of 6. Multiples of 6, we get 6, 12, 18, 24, 30. I'll stop there for now. Then we get multiples of 8. We have, for 8, we have 8, 16, 24, 32, 40, and so on. Okay, so what we do first is, which one is there a common number here, right, that is a smaller? So by that I mean, well, 24 is an 8, and 24 is also a multiple of 6. Is there one that's smaller? So 6 is not, 12 is not, 18 is not. So 24 is the lowest common multiple of 6 and 8. So from that, I know that this is going to become something over 24 plus something over 24. And as we recall from equivalent fractions, well, if 6 became 24, what did it multiply by? So 6 times 4 is 24. Therefore, I'll do it in pencil here. 6 times 4 gave me 24. Therefore, 5 must also be multiplied by 4, like that, which will give us 6 times 4 is 24, 5 times 4 is 20. And then we repeat the same process for this one here. 8 times what gave me 24? Well, 8 times 3 gives me 24. So I'm going to multiply this one by 3 as well, which means 8 times 3 is 24. 3 times 3 is 9. This will add up to 20 plus 9 is 29 over 24. We leave it as an improper fraction there. So we use this basic idea of regular fractions and we apply it to algebraic fractions. Okay, so let's continue. Here we are, we're on question B now. And once again, I want the lowest common multiple between 3 and 5. So I'm just going to write them down here. 3, we have 3, 6, 9, 12, 15, 18. And for 5, we have 5, 10, 15, 20, 25, and 30. Is there a number that's common to both lists? And it's the smallest. Well, I can see 15 and 15 in both. And it seems like they're both the smallest one in that list. So I'm going to stick with 15. So this is going to become something over 15 plus something over 15, like that. Up to question B now. So 3 times what gave me 15? Well, that's 3 times 5. So I multiply this one by 5 as well. So 3 times 5, 15. 2t times 5 is 10t. Same thing. 5 times what gave me 15? Well, 5 times 3 gave me 15. So we multiply the numerator 4t by 3 as well. So 5 times 3 is 15. 4t times 3 is 12t. Adding everything together, this will become over 15 because the numerator stays the same. 10t plus 2t is 22t. Example C. This time it's a subtraction, but it's no more difficult than the ones we've already done. So I think I'll just stick with a pen now. So we'll do 10 and 5. So multiples of 10 are 10, 20, 30, 40, 50. And multiples of 5 are 5, 10, 15, 20, 25. Do we have one that's common to both? Well, 20 is common to both, but is it the smallest one that's common? No. Well, we have 10 and 10. These two are the smallest ones, so we don't want 20. We want actually 10. Okay, so these two fractions are going to become equivalent to something over 10 minus something over 10, like that. Okay, so 10 times what gets me 10? Well, in this scenario, it doesn't multiply by anything. It just multiplies by 1. This multiplies by 1. So it stays the same, actually. So this becomes 7k, because 7k times 1, 7k times 1 is 7k. Next one. 5 times what gets me 10? Well, 5 times 2 gets me 10. So this one here will also be times by 2. So 5 times 2 is 10, which is good. K times 2 is 2k. 7k minus 2k, well, that's 5k. 10 and 10, well, that stays the same. And this one just has an extra step. We can simplify both of them, actually. Because look, 5 and 10, both of them can be divided by 2. So I'll write this one down like this in black. Both can be divided by 2, like that. This can also be divided by the same number of 2. Oh, sorry, not 2. Goodness. 5. Can be both divided by 5. So 5 divided by 5 is 1. So it's going to be 1k, which is just k. 10 divided by 5 is 2. That's where I got confused. And the last one, Now here's where it gets a little tricky, because a lot of people, when they first see this, they're like, oh look, that's not a fraction. But it is actually. This is actually a fraction over 1. We do the exact same process between 1 and 5. So I'll do it here to the side here. Multiples of 1 are 1, 2, 3, 4, 5, 6, and so on. Multiples of 5 are 5, 10, 15, 20, and so on. What is the smallest multiple that's common to both? Well, the only one I can see is 5. 5 and 5. Okay, there's none that's smaller. Okay, so this fraction is going to become something over 5 minus something over 5. Okay, so for 1 to become 5, we need to multiply by 5. And 2y is multiplied by 5 as well. So 2y times 5 is 10y. And 5 to become 5, well, that's just times by 1. That remains the same. This is going to remain the same. 10y minus 4y is 6y, and the 5's remain the same. So that there are examples on adding and subtracting algebraic fractions.